Hello, class. It's nice to be able to actually put faces to the people that I've commented on discussion boards with this entire semester. But before I am able to actually see your face, let me introduce my presentation. My name is Kai Scott, and my presentation is on mathematical concepts in volleyball. I'm sure that most of you already know what volleyball is and how the game is played, but if any of you don't know what volleyball is a team sport in which two teams of six players are separated by a net. Each team tries to score points by grounding the ball on the other team's court under organized rules. Now getting into mathematics in volleyball. Mathematics is deeply woven into nearly every aspect of modern sports, and volleyball is no exception. From the parabolic arc of a serve to optimizing player positioning, mathematical principles are essential for mastering the game. While spectators often focus on athleticism and teamwork, beneath the surface lies a framework of mathematical models that govern motion, strategy, and decision making. This presentation explores how concepts such as geometry, algebra, statistics, probability, kinematics, and optimization theory enhance both play and tactical planning in volleyball. First, we have geometry. What does this have to do with volleyball? The W formation. Players are typically arranged in a shape resembling the letter W on the court during defense. The players' positions form certain angles to optimize court coverage, making sure they can intercept the ball in various directions. The angles of attack and defense, as well as player spacing, are key in covering the most area with the least movement. Here I have given a image of the W formation. We can use this line right here, pretend it's the net. There is six players. We have one here over by the net, which is not included in the W formation, which is the setter. And the rest of them are lined up for defense, in which these angles are to optimize the most coverage. The parabola. What is the parabola? The parabola is a symmetrical, open plane curve formed by the intersection of a cone and a plane parallel to its side. A U-shaped curve that you often see in graphs or in the path of objects in motion. What does this have to do with volleyball? When a player serves, passes, or spikes the ball follows a curved path mathematically modeled as a parabola. Some examples of parabolas in volleyball include jump serve, which the ball arcs over the net, reaching a peak height before dropping into the opponent's court. A set, the setter pushes the ball in a high, predictable parab parabolic arc for the spiker to hit. A tip, which light hits the arc gently over the block into the open space, also follows a parabolic path. Here I have given an example. We have the net here with a player. We'll call this Team A, and another player we'll call this Team B. And we have a player spiking the ball, and it will come up, hitting its highest peak, and then down into player B's court, hopefully touching the ground to score a point. What is statistics? Statistics is the branch of mathematics that deals with collecting, analyzing, interpreting, presenting, and organizing data. Statistics in volleyball. Statistics form the backbone of coaching strategies, metrics like serving accuracy, hitting efficiency, and block success. Rates allow teams to measure performance and identify trends. An example of statistics in volleyball would be, for instance, if a player's hitting percentage drops against taller blockers, coaches might adjust this accordingly and put either a taller player up against the taller opponents or someone who has a higher vertical jump. Kinematics in volleyball. What is kinematics? Kinematics is a branch of physics that studies how things move, focusing on the motion itself and not the forces causing it. Kinematics in volleyball. Kinematics in volleyball involves the study of motion, how the ball and the players move without considering the forces causing the motion. Trainers can use kinematics in volleyball to measure an athlete's performance. It can help players work on increasing their takeoff speed to improve their vertical jump, and also for coaches so they can plan timing on sets and spikes using jump duration. An example of kinematics in volleyball would be if a volleyball player jumps straight up to spike the ball, and we want to find out how high they jump based on how fast they leave the ground. Probability theory in volleyball. Probability theory plays a significant role in decision making. Every serve, set, and spike involves weighing success rates. For an example, players might choose between a high-risk jump serve with a 70% success rate or a safer float serve at a 90% success rate. Game theory also applies. Setters may randomize sets to make the attack pattern less predictable and more effective. Optimization theory in volleyball. Optimization theory further enhances training and strategy. Coaches aim to maximize performance while minimizing fatigue and injury risks. Ultimately, mathematics is not just a background tool in volleyball. It is fundamental to the sport's mechanics, strategy, and player development. Geometry and algebra shape ball trajectories, statistics and probability inform decision-making, kinematics refine physical execution, and optimization theory strengthens both training and in-game strategy. Mastery of volleyball demands not only physical skill, but also an understanding of the mathematics underlying every play. Through this fusion of athleticism and mathematics, players and coaches unlock new levels of performance and strategic sophistication. Thank you for watching my presentation. I hope that you enjoyed it. I very much enjoyed this class and enjoyed learning about all of the different theories in math and how they are applied to everyday life and jobs and where they came from, where they originated, and would definitely recommend this class in the future. Thank you for watching.